Hi there and welcome back at the instructional videos for the Utrecht University Introduction to Bioinformatics course. Topic 2, still metagenomics. We're now at exercise m06, sorting the bamfiles. So you should have by now finished the back mapping step. Perhaps you are still running that step, so BWA mem and some tools are still mapping and storing the reads in bamfiles. What a good idea is to at least check if that's going okay and if it's finished. So let's see, I now already opened the m06 tab, sorting bamfiles, and I put this one cell here in between. And then just before I listed whatever is in this folder, I saw two files, E1 and E2, indicating for me. So let's go back to the loop we just wrote. Click. E1, E2. So it was, let's say, 1/4 at E2. By now, if I execute this again, all files are there and the step finished successfully. Remove that, Some tools view. So, like I said before, it is really good practice to always check the results of your experiment and see if what come out fits with your expectations. So, data/mapped. I'm running some tools view, data/mapped. I'm just picking one of them. You see all 6 are there, but I picked the first one. And since these are really big files, so let's be complete, let's check that again. SH for size and human readable, data/mapped. There's a bunch of big files. I don't want to open the entirety of these files in my terminal, so I use the head command. Let's see what happens. And that's still a bunch of data. So what's happening here is that there's some tools, it opens this BAM file, converts it back to a SUM file, which is this human readable table-like format. But these tables are so incredibly wide that they never fit on the screen. So let's see, all of this is one line in the table, and then here is the second line in the table. So let's see what's in here. What we have is the name of the read. There's a number. I think this is where it maps on the scaffold. We'll get back to that. There's the scaffold name where it maps to. This is actually the position on the scaffold. And I, honestly forgot what that is. So read this maps on this spot on that scaffold. Okay. So that I guess makes sense. Node 472. So you may remember this is what the scaffolds are named in the original assembly. Looks good. You could do this for all. I'm not going to. Moving on. So for further processing, the format that we have our data in now, like this, it's okay, but it's not perfect, it's not very organized. So the way this works is that BWA, the program we just now used to map these reads, takes the reads in the order in which they appear in the file and maps them in that order. That's not per se a very logical order. What's much nicer, so let's say that we have an assembly with not different context, but let's say they're actual chromosomes. What is much nicer is to have these reads map in order of chromosomes and then in order of the position on these chromosomes. That's a much more organized way. And if you then want to have a second program to, for example, count reads per chromosome, then the program can count on all of the reads per chromosome being in one part of the file, and then for the other chromosome in a separate part of the file. In other words, we want to organize this, we want to sort this file. How do we do that? We do that with some tools sort. So again, before we start, let's make a directory where we store our sorted files. I'm going to call this data/sorted, following my own suggestion. Okay, that's done. And of course, we now know that we should have a look at the manual. So return some tools sort. What does this look like? Usage, some tools sort, then there's all kinds of options, and then there's an input BAM file. It's funny that it's not even obligatory. What are the options? There's a compression level, we're not going to compare about that. The maximum memory per thread, we're not going to care about that. Sort read by name, so this is sometimes something that people select in this course. We don't need that, we don't want to sort the reads by the name, so we don't want to sort the reads by their name, which is completely technical arbitrary. No, we want to sort it by the coordinate on which they map onto our reference, which is a much more organized, much more logical way. We could choose for an output, but we don't have to. So it's as simple as that. And then there's again the loop. So loops can be tough. So let's just test a loop as it is now. Okay, it seems to work. So what will this look like? I'm just looking at what I just saw in the usage line. It will be something like some tools sort. Then there's the input BAM. So how would this normally look like? I just remove the $I now, so I can use autocomplete data/mapped/e1.bam. So this is how it would actually look, but remember, I'm doing this in a loop. I want this e1 part to change every iteration of the loop into the variable which is called $I. Okay. And then the way I like it is to make a new folder that contains all the sorted files. So there's this option here, O file, write final output to file rather than standard output. So I guess I haven't done this until now, so I can explain that now. Long story short, there's two ways to kind of reach the same. If I now execute the command as it is, it will output these sorted BAM files to the terminal. This web page will be completely overloaded and I have to do this again. That's not what we want. So we can direct the output by writing an arrow like this to data/sorted/ so I would call it e1.sorted.bam, just to make it impossible for me to ever mix up the files. I put it in a directory that's called sorted, and I even put sorted in the actual file name. That makes it for me kind of impossible to mix up these files. And of course now e1 I replaced by the variable $I. That's it. That's one way, and this will work. The alternative way, can we duplicate the cell? Copy, paste. Nope, copy, paste. There we go. The exact same thing. So let's leave that one intact and have the manual here in screen. The exact same thing would be to use this option. So options go in front. I think it works fine if you put it after, but we do what the manual says, sort -o, and I put again in that file. Remove this arrow, shouldn't be there. So I do the command sum_tool_sort, I give an option -o, the output file, and then comes the input file. Just as in the order as the manual says I should. I personally find it counterintuitive to have the output before the input. I guess it also works the other way around, but for some programs you really need to have the options first and the argument second. With some tools you're fine either way. We run this, we wait for a bit, and I'll pause this video and I'll be back in a second. So I'm back just for an intermezzo. My sort job is still running. I can see from the green dot over here. And I want to know if it's done, if it's producing any output files at all. So I typed ls here, I hit return, but nothing happens. So Jupyter notebooks can only do one job at a time. But we could do two things. We could go to different notebook, type in an extra command here, ls data sorted, and we'll see the output. You could even type sh behind, size human readable. If you execute this a couple of times after each other, you may notice the files grow. Nope. Okay, apparently not happening. One more time. Yep, and it did. And another option is to go to the files tab that we have over here, data sorted, and you also see the files slowly being created in here. Yeah, we'll just have to wait for a bit. Okay, so all the files are in and they're now sorted. The job is finished, as you can see in this square here, and also this command now ran just after this one was finished. So of course we always check if the files were actually created. We just saw this, but let's do things properly. Data / sorted and see what happens. I'll just see how big they are, and the funny thing is, well, I find this funny. So notice the size of these versus the size of these, the ones that we originally mapped. The sorted ones are a lot smaller. That's perhaps weird at first sight because it's the same data just in a different order. So it shouldn't be smaller, and that is true if the data were not compressed. So this is compressed data, and the fact that it's now sorted actually allows for a lot more efficient compression, hence these files are a lot smaller. I find that funny. Now let's have a look at the content of the files. So we use SumTools view again. Go to data / sorted, and I pick again the first one. And I type the head command not to overload my notebook. So what's funny to notice now, no, what's not funny, it's important to notice now. We again have the same columns. The way it's visualized is not very convenient, I realize, but let's look at these columns. The first one, the second one. In the third column you now see that it starts with node 1 opposed to, what was it, node 472. Then moving on to node 1779. Now we're starting with node number 1, and all these initial hits are node number 1. And the position at which they start, they also increase from 18, 65, 579, etc. So the sorting that we did clearly was efficient. It's now sorted firstly by scaffold name or number, and secondly by position on that scaffold. There's a lot more information in this BAM file, but we're not going into detail about this. If you've come this far, well done. You've now successfully mapped your sequencing data to the assembly, organized this in BAM files, then sorted these BAM files, and now these BAM files are ready to be used in all kinds of subsequent programs. Well done, and I see you in the next notebook.